Okay, our last type of question we're going to look at with Newton's laws is when you have something that's on an inclined plane or a ramp. So for this example, let's suppose we have a ramp that has a 30-degree angle at the bottom. We have a box just sitting on there. So if the box is heavy enough and there's good enough friction, the box is going to slide down the ramp. Or we could think of questions where we have to push a box up a ramp or something like that. They all work sort of the same way. So the key thing you want to be careful of in this case, it's similar to the ones we did yesterday, except it's our gravity that causes problems. So in this case, our gravity is going to go straight down. It always points down towards the earth. And then what's different this time is our normal force is going to be perpendicular to the surface. And we also have some friction going on, and our friction is going to slow down this thing from sliding down the ramp. So it'll look something like that. So those will be our forces acting on the box. So you can see here we can't just simply add or subtract. And when we did the last lesson where we were pushing down at an angle, our applied force was at an angle, and we had to figure out the horizontal and vertical components to figure out our normal force. You can see here now our gravity is vertical and our other two are at an angle. So what we do quite often with a question like this, let me just add, I missed an important part. Let's suppose we have the mass of the box is 15 kilograms, and let's use a coefficient of friction of 0.13. Okay, so there's our scenario. The question then would be, what is the acceleration of the box? Does the box move, yes or no? And if so, what's its acceleration? So like I said, it's similar to the other questions, except the problem is now our vertical and horizontal components are all messed up because we got this ramp. So what we do is we actually change this question so it's going to be similar to a previous question, but instead of making it vertical and horizontal, we're actually going to use the ramp as sort of our frame of reference. So in this case, what we're going to have to do is we're going to change our gravity, and we're going to make our gravity counteract the normal force. So that component of the gravity, and we're going to call that one the perpendicular force because it's perpendicular to the surface. So our perpendicular gravity then will be opposite to the normal, and they should be equal. And then our part of the gravity that's parallel to the surface will be our force that's going to cause that thing to slide down the ramp. So that one and our force of friction will be the two that we're going to be dealing with for our calculation. Okay, so the other trick is if we actually make these similar triangles, and if you kind of take this triangle I just drew at the bottom, this is our 90 degree, that was our 90 degrees. So if we spin them around, they end up being similar triangles where our angle of 30 degrees will match that angle at the top of the triangle. Okay, so that's it. So we've got our ramp. We want to figure out our vertical, not really our vertical, our perpendicular surface, and then our parallel forces, and that will help us solve this question. So let me just clean this up a little bit. So we'll call that one our perpendicular, and the green one will be our parallel. Okay, so the first step of this question is we need to figure those out. So using our triangle, what we want to do is we want to calculate those two sides of the triangle. So the first thing we're going to have to do is figure out our force of gravity. So our force of gravity is, oops, I got a mess going on here, so let's clean that up a little bit. Okay, so our force of gravity then will be 15 kilograms times 9.81, which will give us an answer of 147.15 newtons. So that's our component of the gravity that's going straight down. So now what we want to do is do the sine and cosine of each of those. So we'll have cosine of 30 will equal our perpendicular component divided by 147. So if we go cos 30 times 147, we get an answer of 127. My thing's going messy here, I'm not sure what the problem is. So our perpendicular force will be 127.4. Okay, so we have that for our perpendicular. Then what we want to do is the exact same thing, but find our sine. So we want to go sine 30 will equal our parallel component over 147. (73.5) plus the negative 16.6, which gives us a net force of 57 newtons. So our acceleration then is our net force divided by mass. So 57 divided by 15 kilograms gives us a final answer of 3.8. And that's it. So you can see we have our question completed. So very similar to what we did yesterday. The only trick to this one is make your triangle out of the gravity component. The angle in the ramp will be the same as the angle in the box or in the top of the gravity triangle. Find your two components and use those sort of as a question, but we're going to solve it where it's tilted. It's going down the ramp, not just simply up or down. And that's all.